So here we are further exploring the graphs of higher degree polynomial functions. So I want to begin with a little quick review here. That if a function f of x is a polynomial of degree n, then the graph of the function has the following. It has at most n real zeros. And we want to note that this is equivalent to saying that the graph has at most n x-intercepts. Now, in addition to this, if a function f of x is a polynomial of degree n, then the graph of the function has at most n minus 1 turning points. Now, we want to keep in mind here, or make a little love note to ourselves, that turning points on a graph are also called relative or local extrema. These are the relative maxima or relative minima that occur when the function changes direction. So in other words, changing direction from increasing to decreasing or decreasing to increasing. Now, to better help us understand what this is saying exactly, let's consider a polynomial, say, of degree 4. So if we have a polynomial function of degree 4, then we know that n is equal to 4. So now, using these 2 points stated above, we can make the following conclusions. Since we know that this polynomial is degree 4, the graph has at most 4 real zeros, which we know is equivalent to saying that the graph has at most 4 x-intercepts. And the second conclusion that we can make is that the graph of this polynomial function is going to have at most 4 minus 1, or 3, turning points, or local extrema. Now, we want to be careful here. So I want you to keep these key words in mind. At most 4 real zeros, or at most 3 turning points. So this does not mean that the graph has a total of 4 real zeros. This means that it can have at maximum 4 real zeros. So in other words, the graph can have 4 or 3 or 2 or 1 real zeros or x-intercepts. So saying that the graph has at most 3 turning points does not say that there are exactly 3 turning points. It says that the maximum possible number of turning points is 3. So in other words, the graph could have 3, or it could have 2, or it could have 1 turning points. So this is a lot of different possibilities for this one graph of degree 4. And you may be thinking to yourself, how is this even helping us? Well, we use this at the start to determine the maximum number of real zeros the graph could have and the maximum number of turning points it could have. But in order to really simplify this graphing process, we want to go ahead and find the x-intercepts by setting this function equal to 0 and solving for x, and then considering the multiplicity of each of the factors and how that multiplicity is going to impact the graph's behavior at the x-axis. So, in order to see how this really helps, let's now go ahead and consider the following examples.